And this is still 2.3. The first thing you heard me say is that interval, my x interval, we want to center it. Well, I know you guys know how to center something, but let's see how to center it with this definition. So we want to center the interval, and let's say our input interval around a point, and this point being, as you keep seeing in the pictures, x naught. Okay, so I mean that's what we want to do. So let's say, for example, you're told to sketch some interval a, b, and we're going to just look at this in one dimension first. We're just going to look at the x-axis. So we don't even care about the y-axis right now. With this point inside, and then find a value of delta greater than 0 such that, you're going to see it written this way in the book, so you know what that means. For all x, we have this definition. X minus x naught less than delta implies that we keep our x within this interval. So all this says is we're going to have some interval, some one low value to some high value, and we want to be sure our point of interest, our x naught's in the interval, but we also want to center it. So if you're given a equals 1, b equals 7, and x naught equals 5, well, the first thing I probably would do is draw number lines. So 1, 2, 3, 4, 5, 6, 7. And so I'm in this interval here from 1 to 7. And that is my x naught. So if I want to keep that interval, I can't go, in other words, what I would like to do is stay at 7, okay? Because maybe that value is important. I want to stay within that interval. I'm looking at the smallest gap here, which is just simply what, 2? Couldn't I just do the same thing here and say, well, if I'm within this interval 3 to 7, then I'm done? Now, as I mentioned, most of you can just look at that and you're done. And you will be able to do a lot of these problems this way. However, let's go through and write it the whole calculus way, so when you do have to center something, you'll know how to do it. So the calculus way says I'm going to use this up here, 0 less than x minus my x naught is 5, less than my delta, which is going to imply, remember you do the plus or minus, so minus delta less than x minus 5 less than delta. Now if I solve this, all I'm going to do is add 5 to each piece. So this implies 5 minus delta less than x, 5 plus delta. Hopefully that's not getting too small. And what I end up doing is I end up looking at these pieces here, and I say, I'm just saying red, so my 5 plus delta equals my right side value, 7, which implies delta, I'm sorry, I write horrible looking deltas. Delta equals 2, in other words, 7 minus 5. I look at the left side here and my left side limit, and 5 minus delta equals 1, which implies delta equals 4. In other words, I can move the delta to the other side and subtract 1. And then what you do is you pick the smaller value. So pick smaller value, which of course in this case equals 2, and hopefully you can see why up here I moved everything and I centered it around 2. Now, like I said, some of you are probably looking at that and saying, good gosh, why did you go through all that I could just look at it. Again, most of you will be able to look at it, and you won't have to go through these steps. Also, in the real world type application, I may not care if it's centered. In fact, somebody mentioned in the other class, I may actually be interested in leaving this interval this wide to see what's happening down here. But this is the steps on how to do it. So again, therefore, the value of delta, I tried to write it slow, but it still didn't come out better, which assures x minus 5 absolute value is less than delta, and also that I stay with this in this interval is the smaller value, and that becomes my delta. And if you notice on the definition was the plus and minus delta, which would make sense why I want to center it. I can't say plus and minus, what's the 1, 4, or minus 4 and plus 2 to be able to follow that precise definition of a limit. I need a plus and minus, meaning I need the same value. And our centered interval is 3 to 5, again our x naught, and then our 7. So in other words, this was our 5 minus delta and our 5 plus delta. Okay, and so that's just using, you're going to see when we're going to go through an example with the xy whole deal, and you're going to say step 2 is centering it. It's just using this technique here to actually center it. All right, don't y'all wish we lived in a world where I could just talk and it would just type out and draw out on your iPads? Me too. I'm already tired of writing. Yeah, but, everybody's like, yeah, you can already do that. They have this voice recognition software. Okay, if you're from Texas, it doesn't work. Trust me. It still calls me Sandy. And then what's really funny is I remember, this has been years ago, I was roommating with my brother, and we had this big house, and he was upstairs, and I kept hearing him cussing. I'm like, what are you doing? And he says, every time you messed up, you had to say, delete that, delete that, delete that. And he was just arguing basically like with Siri, right? And yeah. Y'all ever done the whole Siri thing? Have her call you a different name?
That's the whole problem, that's Siri.
Yeah. And it's like, Siri, call me princess today. Okay, I will call you princess. I was like, maybe y'all don't get as bored as I do. Okay. All right, so let's do, I guess y'all are caught up on the writing. Always yell at me if you're not. So let's finding deltas algebraically. All right, so this is going to be what your problems in your homework are going to look like. You're going to be given a function. I have square root of x plus 1. You're going to be given sometimes the limit, and we'll talk about if they don't give you the limit. You are going to be given this x naught, which is what I'm trying to center my interval around based off of a particular error, which is 0.1. Okay, now there are some times you will be given a problem that they don't give you this. And this is where you use your logic and you say, well, I can find that. I can just simply plug in 0 there, and the square root of 1 is 1. Okay, so remember that, because a lot of times students will say, well, but they didn't give me the limit. And so just simply plug this in to get your actual limit. All right, we want to find delta greater than 0 such that for all x, our definition, x minus x naught. You'll get tired of writing this definition. And then f of x minus my limit less than epsilon. So once again, in other words, I want to know to stay within my function. I'm interested in this limit, this value. Can't get it exactly, but I can stay within some error. My output, I know all this information. I want to know that information. What do I input? Remember the skeptic and the scholar. What do I input? What do I keep this interval to make sure that works? All right, so let's do it. So step one is we are finding the interval. Maybe we should say around x naught, because I always say stuff like finding the interval. Well, what interval? We're looking around x. That says around x naught. It's very crystal clear it says that, right? Yeah, okay. So I'm going to rewrite this. Absolute value, f of x minus L less than epsilon. And let's see if I can kind of keep this stuff where we can still see it. And now all I'm going to do is look up there at that top line, and I'm just going to start plugging things in. That's all I'm going to do. So absolute value, square root of x plus 1 minus my limit less than, sorry, that kind of went away, but that was 0.1. So that's all I did, was just take all that information they gave me and I plugged it in. As you notice, we don't even use x naught yet. Okay, so now guess what? It's time for algebra land. So I do the minus 0.1 less than square root of x plus 1 minus 1 less than 0.1. So all I did was get rid of the absolute value signs. Probably would do some plus ones in there. Okay, I'm just trying to solve for that middle. I'm solving an inequality for x is all I'm doing. And so I have my 0.9 less than square root of x plus 1 less than 1.1. I don't think I need any of that stuff at the top anymore. And so then probably the next thing to do would be to square every piece. So I square every piece. I get 0.81 less than x plus 1 less than 1.21. And then finally, I subtract 1. Okay, so I hope you get to the point in this class where you're like, all we're doing is algebra in here. I mean, that will be a good thing, right? Because that's all we're doing is algebra in here. So, which this gives me minus 0.19 less than x less than 0.21. That's my interval. Again, if you are living in the real world, good for you, right? I will never go to that real world. You're done. That's perfect. I've got my input where I know I need to keep those x values. Now, another thing you should do as a check, where are you at? Hello, what happened? Is this is, you know, what would Cindy do? Alex probably heard this one. What would Cindy do? We all get the bracelets, right? The what would Jesus do? Wouldn't that be awesome? What would Cindy do? You want to buy one? I got one right now, $100 cash. I really don't have one, but I can make one. All right, what I would do is this is my value of interest, x naught equals 0. I would see is that in this interval? Well, yeah, it is. And once again, the reason why, if it's not in that interval, let's say you screwed something up and you had a positive 0.19, and so that would be over here, and it would be rut-row. That's not even in that interval. And so I want you to realize that's what we're doing. We're making an interval around x naught. So if my x naught is not even in that interval, I did something wrong. So again, gives you a stepping stone to say, oh, I made a mistake, I need to back up. All right, so we're leaving the real perfect world now, and we're going back to calculus land. And calculus land says the second part of the precise, again the word precise definition of a limit is we want to center the interval. Now once again, of course, certainly when x naught is 0, most of you should be able to tell right away you're going to pick the 0.191. Okay? And it's easier to see certainly when you have a 0 there. But let's do it our calculus way, meaning let's write the x minus x naught. Sometimes you will see me not write the 0, who cares? Because I'm going to do the plus and minus delta anyway. And my x naught was 0. So I just plug that in. This is where I said this is where I'm going to use 0 now. And so now I do my minus and my positive. Well, I don't have anything else. That other one we had like a 5 in there. Well, if I look up here, I'm going to do the same thing. I'm going to pick the left side, put the left sides together, and I'm going to put the right sides together. Okay, meaning I'm going to let this left side equal that left side. If I solve for delta, just take, however you want to say it, divide by -1, cancel out the negative sign. And I'm going to do the same thing here. Delta equals that value, and I pick the smaller one, which means my interval went from 0 to negative 0.19, 0.21. That was our happy world, right? And now the centering part says, well, we don't want to be happy. We want to do this. Did you watch the video on my page, Alex, of the I try to be happy? There's a spider. Have you watched that yet? Watch it. All right. Makes me, and those of you on my Facebook, watch that video. All right. So, in other words, all this step has done was centered around, let me write X naught there. Okay. Again, me on my test, unless I tell you to do this, especially if it's a word problem, and we're going to do one here in a minute. We are going to do a word problem here in a minute. I may just not have all the words. But in my math lab, they're going to want you to actually do this step. Okay? I mean, you'll probably have two. You probably won't even have this. I mean, you have to do it, but you won't have to answer this in my math lab. This will be the actual answer that they'll want, is the centered interval. Okay, so as I've mentioned before, and let me, because I'm recording this and can't really jump around, again, what I would do is I would look at the graph. I think it's very, very important you know what you're doing, right? And I always tell students to look at the graph, and they're like, well, look at the graph of what? Well, graph, what we had are function, okay? And then what I would do is I would plot the points, negative 0.19 and 0.9, okay? Where did I get these points? I simply plugged in this value here. So in other words, that's all I'm doing is plugging in an X, getting a Y, and then I also plugged in a 0.19, the right-hand X. These, hopefully you recognize these are my X values. And I got some big old wild number. Okay, so in other words, all I did was plug in this value into there to see what my Y value was. I plugged this value into there to see what this is. And so I plotted those 2 points. And so you could also graph the line. Remember, my limit equals 1 and my epsilon equals 0.1. So you could plot f of x equals 1 plus 0.1, and you could plot f of x equals 1 minus 0.1, and a very ugly, rough drawing of this, would just be something that looks, however it looks. And then I would say, well, this was, let me see if I can kind of draw this where it makes sense. This was my limit. This is going to be, this is going to be my interval, okay? And if some of these other programs are better than the scrapping program I have. If I stay within here, I mean, the biggest thing is I have to ensure that I'm actually touching that function within that limit. Okay, so this is kind of those pictures I showed you in the beginning. It's just a nice way, and I probably will make you hand draw one of these on a test because you get so caught up in all this algebra junk that you have no clue what you're doing. Okay, so this would be a good exercise for you to, and what I mean by I would have you plot it, I certainly would use, either a graphing tool or, something to get your exact values here, and you could plot some points, but to see visually what you're even doing. Okay, All right, and so as I have found out in the past, students love recipe steps. So the definition of how to find algebraically a delta given a function, a limit, an x naught, and an epsilon greater than 0, what we just did, okay? Step 1, solve your inequality, absolute value, f of x minus L less than epsilon. And again, this just gives an open interval. To find the open interval from A to B. And important, as I said, it's a good way to check yourself that that open interval contains your actual point of interest. Okay, so it's got to contain that. And then step 2, when asked to do this, which will always be in my math lab, I will tell you, okay, on a test if you have to do this, is we're going to center it. We're going to find this delta greater than 0 that places the open, sometimes I even look at my writing and go, what's that? Delta greater than 0 that places the open interval that we found right here in this whole x naught minus delta and x naught plus delta. In other words, it centers it at x naught inside. Okay, so those are the 2 steps that you'll do for all of these type problems. Let me go ahead and do the, I ain't got my paper, but I will put it in Blackboard. I have a word problem where it's and you can just say this is a grinding engine cylinder, if I can spell cylinder, forget that E. And they've given you the area of a cylinder, the function for it, equals pi times x over 2 squared. Okay, this is all information that's given to you. It'll make way more sense when you actually see the word problem. And they tell you to look for an interval to hold x to make this area of this cylinder stay within this limit and make that happen with this small error. Okay, it's just another example to go through the actual steps. Now, this is an example here with if I'm designing some cylinder, I could really care less if I center my values. But let's just, for the sake of going through the example, I'm going to plug this in. So I'm going to have pi times x over 2 squared minus 9. Oh, let's be lazy and skip a step. Let's go ahead and do our plus and minus 0.01. In fact, I think this is my math lab problem. I think this is one of your problems. It's one of your 99 problems, and I'm not one of them, right? All right, so I'm going to add 9 into every single piece here. Okay, again, as you can say, I'm basically teaching you 90% algebra. And so I get 8.99 less than or equal to, let's go ahead and write this as x squared and pi over 4. Did you see what I did? That was math magic, right?
What's that number over there?
You asking me? That one?
No, the one on top.
That one?
Top of the 9.
On top of the 9.
Okay.
Oh, adding 9.
Yeah,
And that was a
top of
line.
The number top of the 9, the first one.
This 9. That 9.
Yeah.
That's crystal clear. Negative 0.0101. That's good handwriting right there. It looks, I was gonna say, it kind of looks like an alpha, yeah, it's a delta, okay, whatever. All right, so all I did here was square this, bring it outside, square the 2, that's where I get the 4, and blah, blah, blah. All right, so I get 9.01, and the only reason I did that is now I'm going to multiply every single piece by this. 4 over pi, 4 over pi, and just sake of not having to write it again, then my last piece is I'm going to square root, because notice I have to square root that one away. So I'm going to square root 8.99 times 4 over pi, and then square root 9.01 times 4 over pi. And these are the dimensions of the cylinder. It's asking what do I keep these within, and I get these values. And my math lab should tell you how to round. You know, I always ask students will ask me on the test, how many decimal places should I round? And what do I say, Alex? 47. I don't, it sounds like a good number to me. Why are you so worried about how to round? I would be more worried about how to work the problem, right? I don't care. You know, if it's on a test, it would be nice, something like this, that looks like a good place to round because that number changed. If you rounded this at 3, then that probably would not make any sense. But once again, my math lab will tell you the decimal places. Now, so this is saying that how I'm going to actually design this cylinder, I have to keep it within these values. There's really no need to go to the next step and center it, okay? If it's a word problem, typically you don't have to center it. Okay, now you're going to probably call me a liar if my math lab makes you center it, because I don't remember, but something like this, I wouldn't make you center it. So I will get this word problem so you can actually see the words of what we were doing here, put in Blackboard probably today, and then that way you can go